Welcome you all to this video lecture regarding to that of course computer organization microprocessor. In the previous video lecture we saw regarding to the top topics such as memory location, byte addressability, memory addressing, the all those things. So now here we are going to discuss regarding to that of memory operations. So this memory operation will be taken place with respect to that of two operations such as read and write. How this read and write operation will be done over in the memory operations occupations. So normally this read and write operations we also have discussed in our classroom sessions also during the introduction topics. So nothing that here this read and write will do this process such as just for an example I am saying regarding to the write operations. So normally this write operation as do the processing of transferring an information. Simply we can say that this write operation will do the operation of transferring of information from where to where, means from processor to a specific memory location. There if some suppose already a data is there, means overwriting will done. Here with respect to this read operation will transfers do the process of copying of content to a specific memory location. So read and write is nothing that read will do the process of transferring or copying things, uh, data or content, a value to a specific memory location. So here this memory contents as mentioned over there are unchanged. In order to ignite or to start this read operation, the processor will automatically sends what means an address. So with respect to that address sent by the processor, the read things is read operation will be get started, which means that get ignited, which done over in a specific location. So after to that the with respect to that of address to a memory desired location, the memory will senses the content to get readed over there. After to that the memory will automatically do the process of reading the content or data or values stored in that specific address, and it will give an acknowledgement, or it will sends them an information to the top processor. These things done over in the read operation. Whereas with respect to that of write operation, they already said that in the starting of this video lecture, it will transfer an item of information, which means that it will transfer an information or content or anything to that from the processor, from where means from processor to that specific address mentioned over in that read operation. So which means that here this overwriting from the former content of that location will be get accessed over there. In order to get start over this write operation, which means that in order to get ignite over this write operation, the processor again sends us an address for of the desired location to the memory with the data in order to get written over to the top memory location. So then this memory uses that address and access those address, and it will transfer or read the data in order to perform the write operations. So read and then write, this is the process will get accessed. So read will taken place first and then write. So from this we can able to the common thing mentioned over here, this address. So addressing a specific location or space will helps to do this process. So the next thing we are going to here discuss over here is instructions and sequencing. So now we have a clear picture regarding that how the memory location or memory operations can be taken with respect to the of byte addressability and sequencing. So all those things is we have a clear picture. So now here the instructions and sequencing will help us to do the process, how the instructioning is going to get happen, or how the sequencing is going to get happen. So normally this instruction and sequencing will be taken place with respect to that of two important things such as the register transfer notation and assembly transfer notation. So those things will help us to say how the instruction and sequencing will carry forward over there. So the RTN, which means that the register transfer notation and assembly transfer notation. Here, this RTN register transfer notation will says, or will it will says describe the transferring of information. How the transferring of information done means the contents of any locations are donated with placing a square bracket, which means that here in this instruction we have, it has been mentioned over the square bracket. So this square bracket will say that this is an RTN based, which means that RTN based expression things is or a sequencing order has been taken. So register transfer notation will be described by placing a square bracket, whereas the assembly language notations, it is done over like this. Normal instruction we also we saw in the lab sessions and classroom sessions. So here this add R4 comma R2 comma R3 says us that R2 and R3 are the source registers, whereas this R4 is the destination register, which means this R2 and R3 get added. That added value will be placed in this R4 register. So that is has been mentioned over here. Then this load R2 comma R3 says us means what means this LOC, the content at the LOC are unchanged since because of the execution of this instruction, but the old content of the registers are need to be get overwritten over that. So this is the assembly language notation. Simply we can say this bracketed things as say the RTN. So normal things as normal instructions is without bracket or anything, we can say that comes under the assembly language notations. So this instruction and sequencing also differ to the another processor examples such as reduced instruction set computer and complex instruction set computer. So those RISC and CISC we also going to get discussed later to this in the upcoming video sessions also. So that also will carry some sequencing orders, which means that it has also has some different pipelining options. There we can see instruction fetch executions, how the memory get accessed executed, and how it get be right back. All those things is also get taken care of in the RISC and CISC, that we can detailedly get discussed in the upcoming video sessions also. So the two key characteristics we also need to see over in the instruction and in sequencing with respect to that of RISC and CISC we also going to discuss later. So now in this video lecture we just see how normal RTN and assembly language notation is itself enough regarding to this at present things. So automatically for assembly language we see with respect to this, whereas one thing we need to get remind over here is the load and store instructions also get taken over in that RISC and CISC processor. So there this part, the add destination source, we saw regarding this instruction in the previous slide, which means how to say add R4 comma R2 comma R3. There we saw this example like this part. So store instruction carry the source register or source address at the first part and the destination in the last part, which means that from left to right, first thing will arrive the source and destination, whereas in the previous things as add like instruction, we saw the destination and then the source will come from left to right. Whereas from the least significant bit we can see the in the previous add instruction we saw the source will come first and then the destination. Followingly here the destination will come from first and then the source will comes next. So this is the instruction and sequencing done for the example c is equal to a plus b. So here for in order to get execute this c is equal to a plus b, the instruction carried with respect to the top load, we need to give a register for the instruction, which means the variables a and b. So R2 and R3 are given for that. So here this c will do this process, which means that here c is equal to a plus b. This is the equation we need to perform in this assembly language notation. First, in this regard, first we need to give a register for specific variables a and b. So here this load R2 comma a, therefore the a value get carry over in the R2, b value get carry over in the R3. So now we need to add that need to be placed in specific register R4. That R4 gives the values of c. So here this instruction things has been placed with respect to the top 4 bits of carrying things. How this 4 bits of plus 4 bits taken care means here the load will have specific opcode value R2 has a upward value and A also has specific values. So for this particular instruction it will access three addresses, so that only this load R3 comma B comes to that fourth addressing, which means that this, let for an example here I carries the 1000 means here this load R3 comma B will has the address as 1004. So similarly these things has also carry that addressing things. Here this plus 4 says us that with respect to the top originating address 1000. So this is like the addressing, which means that sequencing happen. So this is also practically also saw in our regular lab sessions also, that we practically saw how this orderings, which means that sequencing happened over with respect to the top opcode values is. So the next thing we need to carry over here is the executioning of program. So normally this executioning of program has been done over with respect to that of straight line pipelining. So here this straight line pipelining says is that this is the straight line pipelining, but with respect to that of risk and CISC, there is a 5-stage pipelining options will come there. So that we need we are going to see in detail in the risk and CISC process. So here this sequencing we normally say that as a straight line sequencing. So this straight line sequencing taken care with respect to the top program counter PC in the processor. So this program counter will use us the information in that which means that program control circuit uses the information in that particular program counter, so to fetch and execute those instruction one at a particular time. So for in order for increasing the addresses, so this is called as a straight line sequencing. So in this video lecture we detailedly saw regarding to the top instruction and sequencing. Thank you.